Okay, now here is Chemistry 111 type of reactions 2 lab. So again, in the data sheet, you needed to write down for each reaction the observation of the reaction. And of course, based on the observation, you can decide if it's reaction happening or not. So you will see yes or no. You're going to circle one. Then you are going to decide what type of the reaction, of course, is based on you write the chemical equation. So here's one question, a complete balanced equation. So this time it's different. This time only the reactants are given in the procedure. So you needed to decide based on the single displacement or double displacement, you decide the products and write down in the equation. And also don't forget to balance the equation. And then you, based on the equation, decide what's the type of the reaction. So we still have the 5 different types, but this time we focus on 2. The single displacement or double displacement, or maybe combustion reaction involved. So this is the requirements. Let's go to each reaction. So in reaction 1, okay, so I'm going to put in this corner. Will those be okay? Okay, so here we need to mix the zinc strip to test tube and with the magnesium sulfate. Magnesium sulfate is already in there. Okay, so I'm going to put a zinc strip in there. So you're going to see what happened to it, to the zinc. It may take a while to react. Maybe shake a little. But notice we may have nothing happen. Okay, so there may be no reaction, but we'll give this a little time to react. Okay. Let me take a look. Nothing. Okay, I'm gonna leave it there for a while. Maybe we'll go back to this reaction to see if it's really anything happened. Okay. So I'm temporarily put this aside. That's our reaction 1. Okay. Now let's move to reaction 2. We needed to combine sodium chloride with silver nitrate. In the test tube, sodium chloride is already in there. We needed to mix it with silver nitrate. So I'm going to add silver nitrate. Okay, so the change is very quick. You can see that. So that's our reaction 2. Now move to reaction 3. We need to mix the copper with silver nitrate. Silver nitrate is already in there. Okay, we need to put the copper in. Yeah, those type of reactions kind of slow, so we needed to leave it there for a while. Let's go back to our reaction 1. Anything happen? This is our reaction 1. Okay, this was zinc strip with magnesium sulfate. Okay, seems like, okay, so you decide, all right? Now, take a look at our reaction 3. Originally, it's a shining copper. You can see the copper now on the surface of copper. Anything happen there? Okay, all right. So that's the reaction 3. I'm going to put it away. Now move to reaction 4. So reaction 4 here should be mixing sodium hydroxide with hydrochloric acid. So sodium hydroxide is already in there. So we need to add hydrochloric acid. Okay. What I can tell you is the test tube warms up. Okay, so that's some change as well. Okay, so that's the reaction 4. reaction 5 should mix the sulfuric acid with copper. Sulfuric acid already in there, so I'm going to put copper. Okay, now let's observe. On the copper surface, anything happened? Okay, so that's reaction 5. Now move to reaction 6. Reaction 6, we're going to burn the heptane. So we're going to add several drops in there in the evaporation dish. We are going to burn it. We need a splint, or maybe we need some distance. Ooh. Okay, that's our reaction 6. It's a little hot there. Now move to reaction 7. We need to mix zinc with sulfuric acid. So sulfuric acid already in the test tube. We just put a piece of zinc in there, and you're going to observe the change. You need to give some time. Can you see that clearly? You should really pay attention to the surface of the metal. You can see that? Can you see those bubbles there? It's on the corner of the metal. You can see some bubbles there. Okay, good. All right. Let's move to reaction 8. We need to mix sodium carbonate with calcium chloride. Okay, so sodium carbonate already in there. Okay, we needed to mix the calcium chloride. So this is calcium chloride. So you can see the change. Okay. Now that's reaction 8. Reaction 9. We need to mix 10% sodium hydroxide with 6 molar nitric acid. So sodium hydroxide in the test tube already. Now nitric acid. Sodium hydroxide, nitric acid. I need to fill that. If nothing happened, I want to double check if there's any other reaction. Yeah, it's warm up. Okay, it's warming up the test tube. So there's some reaction happening here. Okay, so that's our reaction 9. Now reaction 10. Iron 3 chloride. Iron 3 chloride there. Iron 3 chloride. Okay. Mixed with ammonia hydroxide. So this is the iron 3 chloride. ammonia hydroxide. Ammonia hydroxide. Okay, reaction 10, we need to add a 6 molar ammonia hydroxide into iron 3 chloride. So I'm going to add some. Ooh, change is very obvious. Okay, let me mix a little bit. Let's see, we can see that. Okay, so that's reaction 10. Now, reaction 11, we needed to add a zinc strip to the lead 2 nitrate. So, zinc into lead 2 nitrate solution is already there. So, we have a zinc and lead 2 nitrate. So, notice the surface of the zinc metal. Whoa, it changes quick. Notice the surface. You can still compare to the original zinc. Okay, very different. All right. Okay, so that's reaction 11. Reaction 12. We'll mix sodium carbonate solution with hydrochloric acid. So sodium carbonate already in there. Hydrochloric acid I need. Notice the small, tiny, white stuff. Okay, let's do it again. Yeah, I think it's not so obvious to observe, so if I add slowly. Ooh, see those tiny, teeny thing in the solution? Or let me add a little more of the sodium carbonate. Okay, I add it slowly, you can see the change. See the change? Okay, good. All right, so that's reaction 12. Let's move to reaction 13. We need a lead into copper 2 nitrate. I wanted to do copper 2 nitrate. Copper 2 nitrate. Okay, we need to put the lead in there. So notice the lead looks like what? Okay, now put it in there. Now observe the surface. This may take a little while. So this is the reaction 13, but I'm going to go back. I'm going to let you visit later of the change, maybe more dramatic. Okay, I'll leave it temporarily away for a while. I'll show you a little bit later. So now let's move to reaction 14. We're going to burn another one. This time we're going to burn ethanol. Okay, so I will add several drops in the evaporation dish. Okay, I'm going to ignite it. start to burn. You can see the flame. Oh, it's kind of run out. Let's do it again. See the flame. Good. Okay. Now let's go back to our reaction 13. Okay, watch carefully. It's a little bit hard to observe. Maybe we'll revisit that even later, let the reaction develop. I'll leave that in the corner. Okay, remember, reaction 13 we needed to observe later. Now move to reaction 15. We needed to mix two chemicals. One is copper 2 sulfate. Beautiful blue color, with zinc nitrate. Zinc nitrate. Any change of the reaction? Okay. So that's the reaction 15. Think about any color change, any PPT. I don't feel any temperature change. And notice if there are any gas bubbles. Okay. If yes, maybe reaction. If no, then you make a decision. Okay. So that's the reaction 15. Now reaction 16. We need to mix the barium chloride with sulfuric acid. Barium chloride. Sulfuric acid. That's the observation. Okay. Now, reaction 17. Sodium chloride mixed with potassium nitrate. Sodium chloride. Potassium nitrate. Okay, that's the mixture. Okay. Now let's go back to our reaction 13. Like I promised, we needed to check the reaction 13. The lead strip and the copper 2 nitrate solution. Anything built on the surface? Let's take out the piece and take a closer look. I'm going to decant it. Get out. Okay. Seems like they're a little bit dark stuff on the surface, so I can wipe them out and happen on my, you can see some of the black stuff on my glove. Okay, I think that's the buildup on the surface. It's really hard to see it directly from the metal piece. Okay. Yep. Okay, so the last reaction, reaction 18, should be mixing calcium metal with distilled water. So distilled water already in the beaker. I'm going to put a piece. You can see that already. So one piece is enough. Okay, so the reaction is going on. I don't like the smell. Oh, it's generating a lot of gases. Okay, afterwards, take a look at the solution itself. Okay, what do you say? All right. Okay, so that wrap up the type of the reaction 2. All right.